In this video, we're going to use the graphical method to calculate the magnitude and the direction of the resultant force. Now, the first thing that we need to do with this method is to ensure that we know what the angle is between our forces and the horizontal axis. Now, for example, this 8 kilonewtons right here, we can clearly see that the angle is 30 degrees between that force and its horizontal axis. When we go across then to the 10 kilonewtons, I'm just going to measure going across like that. So we can see then that the angle between that 10 kilonewtons and the horizontal axis is 120 degrees, because we'll have to add this 90 degrees here with that 30 degrees. And then finally the 10 kilonewtons here, the angle is not explicit there, but if we add the 90 degrees with the 30 degrees, we get 120, and we add another 60 degrees right here. And that will be our angle between that 10 kilonewtons and the horizontal axis. Now let's get into how we draw the vector diagram. So then when you're drawing the vector diagram, your first step is to ensure that you establish a scale. So just make a note that your step one is to ensure that you establish a scale. Now, if you're using some form of CAD software, then you don't necessarily need to establish any scale. You can just use the software to do that. But if you're using, say, your ruler and your protractor, and you're just using the regular centimeter grid paper, then you will need a scale for your diagram to fit onto. For this question, however, we're just going to use a scale of 1 centimeter to 1 kilonewton. So it's just a 1-to-1, and that's because the measurements that I've got there, it's quite simple for us to draw 5 centimeters, 10 centimeters, 8 centimeters, and so forth. But if it was much bigger, let's say 200 kilonewtons we had there, then I would really want to scale that down to perhaps even 100-to-1. So whenever I refer to a reference line, I'm just talking about this white horizontal line that's right here, and I'll be using this red arrow line to draw in the forces. So the first step then is to start off by drawing a reference line, and this here is going to be my reference line that I'm using. This white horizontal line, that's my reference line. So what we do next is just to draw on this line here, which is represented by that red arrow that I've pre-drawn, and because it's 1-to-1, then this would be the 8 kilonewtons that I draw, but in terms of measurement, it would just be 8 centimeters. Now, very crucially, the angle right here between the reference line must be the same as the angle between our 8 kilonewtons and that horizontal line there, which is 30 degrees. So right here, you should have 30 degrees. And let's say we were using centimeter measurements, this would be just 8 centimeters because we're using a 1-to-1 scale. So our next step would be to draw a reference line at the tip of the arrow that we have here. So as you can see, I've just copied my horizontal reference line, place it right at the tip of that arrow, and that's where I'll draw the next force for. So the next one I'll draw is the 10 kilonewtons. So that right there is the 10 kilonewtons that I've just drawn in. And what you need to make very, very careful note of is, one, the angle out here, it must be 120 degrees. So that's the first thing. So the angle between our reference line there will be 120 degrees, or you can draw this inside here as 60 degrees, because as you can see, this right here, we measured that to be 60 degrees. I'm talking about that angle right there. The main goal is to ensure that the angle between the horizontal reference line is identical to what we have on the diagram. So next we're going to draw in that 5 kilonewtons, and that's just a horizontal line, so that won't be any issue in terms of reference lines. So this represents our 5 kilonewtons, which we're using centimeters because we're just measuring these with rulers. So that's going to be that horizontal force right here that we have, which is 5 kilonewtons. And of course, the previous one that we drew in was just 10 centimeters because that measured 10 kilonewtons. Now, because this 5 kilonewtons is a horizontal line, then this can just serve as the reference line for our next angle. So when we draw in our next angle, which is the one for the 11 kilonewtons force, which we need that to be 60 degrees, then we can just simply measure the angle using that 5 centimeter as our reference line. So that represents our 11 kilonewtons, which in terms of centimeter measurements, it's just 11 centimeters right there. Now, crucially, we need to ensure that the angles are correct. So between the 11 kilonewtons and the horizontal reference line, we have over this side 60 degrees right there, or inside here we can measure this right here as 120 degrees. Just as long as it's identical to what we have on the diagram, it is absolutely fine. So now you notice we've got back our reference line at the tip of that last arrow, and that's because we need to measure the next angle using that reference line, and we need to be as accurate as possible. So what we do next, we're going to do that 9 kilonewtons, and it's going to be in reference to that horizontal line that I've just placed there. The angle between must be 60 degrees, just as it is showing on the diagram. So this here will represent our 9 kilonewtons or our 9 centimeters. Now again, crucially, the angles must be in the same position. So our angle between the 9 kilonewtons there and the horizontal line is 60 degrees. And the 60 degrees is right here. So we need to ensure that that's exactly in the same position. Now, just before we get on to the resultant force, I'm just going to highlight a very, very key factor here that we need to maintain. So I'm just going to do this for 3 of the forces, and you will get the point by the time we get to the third one. So let's say we use the 8 kilonewtons, and what I'm going to highlight here is exactly where you should measure the angles. And if you get this point, then you get everything really. So right here, I'm just highlighting right there with that green. That's 30 degrees right there. And if you notice, I've got the 30 degrees on the very, very same side right there as it is showing on the diagram. And of course, the arrow that we draw there for that 8 kilonewtons, it will be parallel with the 8 kilonewtons on the diagram as well. So the angle is a crucial thing that you need to have in the same position. Let's say we use another one. Let's use the 10 kilonewtons. So on the 10 kilonewtons, which is right here, we have our angle. That's 60 degrees there. Notice that the 60 degrees on the force vector, it's in the exact position as it is on the diagram. And that's what will give you the parallel lines being drawn up, and you will have accurate dimensions. We can just take another one. By now I think you get the gist of it, but let's just take another one. Let's use the 11 kilonewtons. So for the 11 kilonewtons, you will notice right here where I'm shading purple, we have that as 60 degrees, and right here same, the 60 degrees is in the same exact position. So you can't make any mistakes once you do that. You just need to get the length of the lines drawn accurately, and of course use the reference lines as you see I've done here. So let's get the resultant force now. So this here will represent the resultant force at the bottom in green. And things to notice here is you will notice that all the forces that on the diagram, they go around in the same direction. But as for the resultant force, it goes back onto those forces. So you'll notice that the tips of the arrows meet there with the resultant right there. And all you would need to do now to get the final answer for your resultant force is to measure that with your ruler. And the angle for the resultant is going to be, once again, you draw a reference line, but the reference line would be drawn, say, right there on the tail end of the arrow, and you'd measure the angle that's between that reference line and the resultant that you just got. But because I've merely sketched my diagram, it's not drawn to scale or anything, it's just a sketch to show you the steps. Then if I should measure this, it would be a bit out. But I've done another video where we have done the calculation method. So if you want to know if your resultant is accurate, then you can check out this video here where I've done another method with this same question. So hopefully that helps, and I'll see you in the next video.